Okay, let's dive in. When you think Arizona, you probably picture endless sun, right? Perfect for solar panels.
Yeah, absolutely. But it's not always that simple, is it? What about when that sun gets so intense, the panels actually lose efficiency?
Right. Or, those big monsoon storms that roll in,
Right.
blocks the sun completely, just pouring rain.
Exactly. That's the core challenge. Your standard solar panels, they really struggle then. High heat cuts production, and rain or heavy clouds. Forget it.
Okay, so you sent over some really fascinating stuff, a white paper, some research notes about this pretty clever idea, combining solar panels with tech that gets energy from rain.
Yeah, falling rain, it sounds a bit odd, maybe counterintuitive, especially for sunny Arizona.
Yeah.
But the sources, they lay out a pretty compelling case for a hybrid system.
They call it rain-powered solar, or hybrid solar tang.
That's the technical term, yeah, hybrid solar tang system.
So our mission here is to unpack this. How does it actually work? Why is it supposedly so perfect for Arizona's, unique weather? And what's the real potential here for you listening?
Well, the fascinating part is how it directly tackles those solar limitations we mentioned.
Yeah.
It adds another layer. The core idea is integrating something called a triboelectric nanogenerator,
A tang.
a tang layer. Okay. Right. Onto or maybe underneath the solar panels.
10-year. Okay, simple terms. The source mentioned the triboelectric effect, like static electricity, rubbing a balloon on your hair.
Exactly like that, fundamentally. Yeah. It's about generating a charge when different materials touch and then separate. In this case, it's raindrops hitting a special surface.
So the raindrop hits.
Uh-huh. The sources describe how these raindrops, they carry a tiny charge, and they hit this special coating on the panel. Each little impact, that touch and separate moment, creates a small bit of electricity.
And they've scaled this up. The sources were talking about, what, up to 200 watts per square meter just from rain? That sounds significant.
It is comparable to a solar panel in, say, moderate sun. So yeah, significant potential during a rainfall event.
And the materials have to be tough, right? For the desert.
Oh, definitely. The research points to robust stuff, transparent composites for that tang layer. They need to handle dust, wear and tear, without blocking the sunlight getting to the solar cell underneath.
Okay, now here's where I thought it got really interesting, especially for Arizona. These tang layers, they don't just make power from rain.
Right, that's a key part. Some designs, the sources describe how they can also act as thermal emitters. Basically, they help cool the solar cell underneath.
Cooling in that intense heat.
Yes, exactly. That dual function is, well, critical. Pilot projects mentioned in the sources show they could drop the solar cell temperature by over 24 degrees Celsius,
Wow.
which directly fights that efficiency loss problem from panels getting too hot,
So you've got your solar panel, maybe even those bifacial ones catching light from both sides.
which could also boost yield. Yeah, the sources suggest that possibility.
And then you add this tang layer.
So dry and sunny. The solar panel works, maybe boosted by being cooler, maybe by the bifacial aspect. Then the monsoon hits, the tang layer kicks in, converting rain energy.
So it's generating power when solar usually just, well, stops and slows way down.
Precisely. Cloudy, rainy, even super hot periods.
Right.
You get more consistent power generation.
Okay, beyond just making electricity, are there other benefits? You mentioned cooling.
Yeah, so there's that potential for urban heat island mitigation.
Yeah.
If you have a lot of these panels, that cooling effect could actually help lower local temperatures a bit.
Cooling the air around them. And what about the water itself?
Good point. The panels can also be designed to just collect the rainwater.
Hmm.
The prototypes show pretty high efficiency, like 83%, at capturing the water that hits them
And you could use that water.
for cleaning the panels,
Yeah.
right? Keep the dust off, maintain efficiency. It creates this really smart sort of resource-efficient cycle. Water capture, cleaning, energy generation.
What about the cost? Is this actually, viable?
Well, the sources paint a promising picture economically. Yes, there's an extra upfront cost for the tang layer, but the analyses show pretty reasonable payback times. And commercial-scale projects are apparently producing energy at competitive rates. Plus, because rain energy often comes at different times than peak sun, it complements the solar cycle. It adds resilience.
It smooths things out for the grid.
Exactly.
So, wrapping this up, what does this all mean for you, the listener? These hybrid systems, they're not just some lab curiosity. The sources suggest they could seriously boost the total energy you get from one installation, like 25, maybe 40% more energy?
Yeah, compared to just solar on the same area,
Yeah.
that's a big jump.
Huge jump.
And looking bigger picture, the projection is that this kind of tech, this hybrid approach, could maybe supply I think the number was up to 35% of Arizona's total electricity needs by 2040.
35%, wow.
It's about using all the weather, sun and rain working together.
It really makes you think, doesn't it? What if we stop seeing things like intense heat or heavy rain just as problems for renewables?
Hmm.
What if we saw them as like untapped energy sources just waiting? What could that shift in thinking mean for, well, grid resilience and clean energy everywhere?